part of what you do in modeling something like an epidemic is that you're looking to see how the population is changing with time as the disease is spreading. The idea is that we can take our population of people, and we're going to have some kind of closed society group of people that we start with, and initially everyone is going to be in this society. We're going to take a simple model where no one is immune from infectious disease that is going to be introduced. And then what we'll do is introduce an infected person. It could be one. One of the things that we could look at is that it doesn't really matter initially if we put 1 or 10 or 100. The rate of the epidemic, the increase in the epidemic is kind of insensitive to that. So let's say this infectious individual ends up making a contact which would be close enough to transfer the infection. And then that person that is here, this individual, could become infectious. And then what you would have at the next step is 2 infectious individuals in this population. And then the others, maybe people are moving around a bit, but you've seen an increase in I and a decrease in S. And then maybe this infectious person is going to contact another susceptible person and spread the infection. But this infectious person who has had the illness for a while is going to recover. We're dividing the population into 3 groups, or 3 types of individuals, or 3 states essentially for each individual. You can start as susceptible, and you introduce an infectious individual. The people are moving around and they contact each other with a certain rate, some number of contacts per day. And then that can spread the infection, but then as time goes on, you can also see individuals recover. So if you double the number of susceptible people, a fraction here, you would double this rate. Or if you double the number of infectious people, it's twice as likely that you contact an infectious person. And then you have to introduce a constant here. This is a key constant, K. K is equal to the number of contacts per day. So if it's like, 10 contacts per day, then you would have 10 of these events that could transfer the illness. This is called the SIR model for susceptible, infected, and recovered model. And it's the sort of the classic model for modeling infectious disease transfer. And so social distancing is entirely about reducing the reproduction number below 1. We can't change K, the recovery period, but we can change the contact number. You have contacts between people that are transformative. They change the nature of the person. And you have people that are, transitioning through 3 phases, or staying the same throughout the epidemic. They're untouched. But others that follow through 3 phases of change due to, their particular history of contacting another individual.